This is a question of assertion and reason. Assertion is specific cutting energy for grinding is higher when compared to other machining process, and the reason is the active grinds have large negative rake angles. Here, the grinding wheel consists very active grind, so that's why it has a large negative angles. So that's why it requires more cutting energy. So specific cutting energy is for grinding wheel higher when compared to other machining process because of it has active grinds and they have large negative rectangles. So here both A and R correct, and R is the correct estimation for A. So here the correct answer is A. A is the right answer. A steel wire is drawn from an initial diameter of 9.9 mm to a final diameter of 7.7 mm at a speed of 2.2 meter per second. The half cone angle of the die is 7 degrees and coefficient of friction at the job die interface is 0.11. A tensile test on the original specimen gives a tensile yield stress of 222 Newton per mm square. A similar specimen shows a tensile yield stress of 444 Newton per mm square at a strain of 0.55. Assuming a linear stress strain relationship for a material, determine the drawing force required. No back tension is applied. Here the options are 11.6 kN, 19.1 kN, 11.6 Newton and 19.1 Newton. Coming to the solution, first we will have to find out the average yield stress of the material or the yield constant of the material. So here we have two relations. One is we have two known values. One is the strain. The true strain is given by ln of ai by af, which gives a value of 2 times ln of di by df, where di is the initial diameter of the wire and df is the final diameter of the wire, and which is equal to 2 ln initial diameter is 9.9 and final diameter is 7.7, which is equal to 0.503. So here we got the strain, and we'll have to find out now the final stress of the material, that is yield stress at the end of the operation for the given material, and is given by the final yield stress is equal to initial yield stress plus the yield stress at a strain of 0.55, that is 4.444 minus 222 by 0.55 into the 2 strain, which comes from the above equation, that is equal to 0.503. So this is equal to 424.9 Newton per mm square. Now the average yield stress is sigma y is given by average of final and initial yield stresses, that is 222 plus 424.9 by 2, which gives a value of 323.5 Newton per mm square. And here drawing force is given by equation of sigma x into af, where af is the final cross sectional area of the specimen, and here sigma x is given by an equation of sigma y into pi by pi minus 1 minus df by di whole power of 2 into pi minus 1. So this is the given equation for sigma x, where pi is equal to 1 plus mu by tan alpha. Here alpha is half die cone angle, which is given by 7 degrees, and mu is coefficient of friction between the die and job interface, and here pi is equal, from those two we get here pi is equal to 1.9. Substitute all the values. Here sigma x is equal 323.5 into 1.9 by 0.9 into 1 minus 9.9 by 7.7 whole power of 1.8, and which gives a value of 248.5 Newton per mm square. Now the drawing force is equal to sigma x into AF, so and is equal to 248.5 into pi by 4 into the final diameter is 7.7 square and is equal to 11.6 kilonewton. Here the right answer is 11.6 kilonewton, and in the options the right answer is A. A is the right option. The following list 1 with list 2 by using the codes given below. List 1 gives unconventional machining process. List 2 gives mechanics of material removal of the concerned process. Here in list 1 we have VSM, ultrasonic machine, EDM, electro discharge machining, ECM, electrochemical machining, and alternative beam machining, EBM. And the list 2 consists brittle fracture caused by impact of abrasive grains, and the B is electrolysis, C is melting and evaporation, D is melting and evaporation by aided by cavitation. So here, so if you consider the options here, there is matching 1A, 2B, 3C, 4A like that. So here the first consider USM. So in ultrasonic machine, brittle fracture caused by impact of abrasive grains. So this is the matching for ultrasonic machine, that is 1A is for 1A is the correct cut matching. And consider EDM. So electro discharge machining, it is done by the metal removal process in EDM is done by melting and evaporation aided by the cavitation. And in electrochemical machining, it is done by the metal removal is done by electrolysis, and in electron beam machining, it is done by melting and evaporation. So here the right answer is B. B is the right answer. Z is equal to 3x1 plus 2x2 subjected to the following constraints: 4x1 plus x2 less than or equal to 60, 8x1 plus x2 less than or equal to 90, 2x1 plus 5x2 less than or equal to 80, and x1 comma x2 greater than or equal to 0. Just write down, just draw a graph taken as x1 and x2 are coordinates. So for the 4x1 plus x2 less than or equal to 60, it gives a value like this, and for 8x1 plus x2 less than 90, it gives a value like this, and here 2x1 plus 5x2 gives, so that the feasible solution occurs in between these coordinates. So therefore the number of corner points for the feasible solution are 4. These are the 4 corner points for the feasible solution. That is in the options the correct answer is B. B is the right answer.